Okay, so what we're going to do here is we're going to go through the question 2A on the mock paper for this year's summer exam. So the question itself is a 2006 higher level question 6, section B obviously. There's 100 marks rewarded for this in the exam itself, so it's a full marked question. Now, let's just give it a quick run through and then we're going to go through the actual construction of it. So A to B, so the curve AB is a parabolic with a vertex of A. So this is the vertex of A, and it's in parabolic curve AB. CD is identical, so CD is identical, or CB is identical. Okay, so straight away what I'm thinking there is just mirror the whole thing over. The curve DEF is elliptical. Okay, so DEF, an elliptical shape there. Okay, the curve DGF, so that's DGF, is a portion of the same ellipse. Okay, so that's an elliptical shape too, and what we're going to do is we're just going to actually mirror the ellipse over from there. Okay, perfect, no problem at all. Draw the given design, show all constructions clearly. Okay, so let's have a look at this diagram and let's kind of do it more so. So if we're looking at this, the first thing we're going to start off with is this parabola here. So it's A, B and C, right? So 50, 70, 30, meaning it's 150 rectangle. 150 times 26 plus 34 is 60. Okay, so 150 times 60 parabola. Okay, and make sure the vertex is at A. Okay, now the next thing is we've got our ellipse and we've got a major axis of 70. Okay, so straight away I'm thinking I can draw that in straight away. And we've got 2 points. We're not given the minor axis. Okay, we're given 2 points, F and D, which are on this AC line, 26 mil from the center point. And what we're going to do is we're going to have to find that point. Okay, now, so if we flick over here and we're going to go through the animation for it. Okay, so step 1, as I said before, is going to be to draw the outline 150 times 60, which is going to make up your I suppose it's going to make up half your parabola. Okay, so when we've done that, remember now A is the vertex. Okay, so we're going to break up the lines. Remember, any angle at all, break it up 5 to 6 times. In this question I've done it 5 times. Okay, so you can make that every 10 or 20 mil. Connect up the last point here to the point, the corner of the rectangle, and then all these angles here, all the same, these lines, what you're going to do is you're going to go sliding set squares and going to keep that angle the same. Okay, a common mistake you guys make here is that you connect this last point up to some random point here, and that's not what I want you to do. I want you to connect it to the last point there on the rectangle. Okay, so after that, what we're going to do is we're going to copy this angle all the way up here, and that's going to divide up your 150 here into 5 equal parts. Okay, now the next thing is the exact same process from point B here, and again 5 equal points. Connect the last point up to your corner and copy the angle, sliding set squares the whole way. Perfect. Now what we're going to do is we're going to connect these points here. So along this line here, we're going to connect them up to the apex, which is A. So we can see that there. We're going to connect them all up there. Perfect. So kind of, I suppose the second to last step is actually going to be to draw these lines straight down. Okay, so again, this is just a basic parabola. We've got all our points there. Where we've got our points, remember, it's always, I find it always easiest to start up here. So the first line to the first line, second line to the second line, third line to the third line. Going to draw a nice little even curve there. Perfect. Now, what we're going to do now is we're just going to mirror the whole thing. So we're going to draw our lines. We have our points. We're going to draw them straight down vertically through our axis, our center kind of axis here, and we're going to just take our compass, take the measurement from this center point here, or the center axis here, out to your point, and then strike an arc with the same length on the opposite side. Okay, and you just repeat that process 5 times. Okay, So now we've got the parabola, and that's roughly about 50% of your grade got there, okay? So now we've got that in. Now, so I suppose what makes this the honours level question is that we're not given all the points for this ellipse we're about to draw. Now, so we know the centre point is 100 back from point B there. Okay, so the centre point is 100 back from point B. And then we're going to come out 70 to find the major circle. Okay, so literally draw an arc of 70 mil all the way around, full circle, with a radius of 70. Okay, now we're given points F and D. They're 26. They're on this line AC, and they're 26 mil up from the center point. Okay, now what we're going to have to do is going to look to locate. We're going to look to locate the minor axis from these 2 points. Okay, so what we've got to do, and it's kind of reverse engineering, is we've got to draw a line down vertically. Okay, and then we're going to connect it up to the center point. So draw it vertically until it hits that major auxiliary circle and connect it to the center point. And when we've done that, what we're going to do is we're going to connect it from D all the way here across, okay, till it hits this divided line. Okay, so what we've done there basically is we've gone from D, we've gone parallel with the minor axis, until it hits this major auxiliary circle. We've connected that to the center point, okay, and then what we've done is we've come from point D again, and we've gone parallel to the major along this line till it hits the divided line. So we've put a kind of an auxiliary divided line in there, okay? And what we're going to do is we're going to work out where the minor auxiliary circle hits that auxiliary line. And where it does, we can just place our compass in the center, mark it out to this point here, and draw our circle, okay? From this point here, it's just like any ellipse question. Divide it up with your 30/60 set square. Where it hits the major circle, you go parallel to the minor. Where it hits the minor circle, you go parallel to the major. Now, so we're going to do that. Draw in our curve. Perfect. Yep. Now, the last, well, I suppose the second to last step on the process is actually going to be to draw your ellipse in there, just like so. And again, keeping your lines really neat is going to help you in this question, because there is quite a lot of drawing in it. Now, so last but not least, what we're going to do is we're going to actually have to put this elliptical curve in here from F to G, okay? So what we're going to do is we're going to mirror this part here of the ellipse, okay? So what we're going to do is we're going to pick some points along here. So we're going to draw random lines through, and we're going to take our compass, okay, so that's just and we're going to take the length from here and strike it here. So what we're actually doing is we're saying that FD is an axis, okay, FD is an axis, and we're going to kind of mirror this shape here on this side of the axis, okay? So draw a line through there, mark the same distance from here to here as to here to here, and same thing here. Perfect. Now we draw in our curve like so, and that is the question finished. So key things with that question is you've got to be able to reverse engineer the point here, and also to keep everything nice and neat, because there's going to be a lot of lines in it, okay?